Hey everybody, Mr. Palacios here, and today we're going to look at these two equations. We have the function of x. We have two different functions. And this one, x squared, we're going to see how to get from this one, which is x squared, to this one, which is x minus h squared plus k. So we're going to take a couple steps at it. This is going to be a three-part video. Just know that each part of it is geared towards getting you closer to this final product. Okay, so we'll be starting with this, and then we'll be looking at what happens when we add another number to the equation, when we add another variable to the equation. So in this instance, we're just going to start off very simple. We're going to do x squared plus 2. Okay, so last time that you guys were graphing, you just did a normal x squared function. The origin 0, 0 of the y-axis and x-axis. The origin is where our vertex was, and the lines came up off of it, sort of like this, like a giant U. And you notice that once you got past like the third number, it was almost impossible to graph anymore, just because your graph wasn't that big. Well, if we're taking a look at x squared plus 2, that's going to move the vertex a little bit. So right here, what you want to know is what is going to get us to 0. Well, it would have to be a negative number, and in this case you can't really get that because x is squared. So even if you started with a negative, it's going to be positive by the end of it. Okay, so this is basically going to tell you where the vertex is going to be when you have a function that's just like this. Okay, if we set x to 0, then automatically our y coordinate is going to be 2, and so our vertex is going to be at 0, 2. So if you have a function that looks like this, finding the vertex is actually very easy. Okay, and just know that it's not going to get any lower than this. Okay, now we're going to graph this out. So we'll take -1, -2, -3, and then 1, 2, and 3, and you notice we get 11, 6, 3, 2, 3, 6, and 11. I graphed those out. Obviously, I couldn't really get past 6, so I have 0, 0, 2, -1, 3, and then -2, 6, and then I have 1, 3, 2, 6, and that's all. You can go up to 11 if you want to. I just thought that was a little too much. That's the great thing about graphing like this, is that once you get past like the first two, you kind of can stop because it gets a little much. Okay, now what happens if we subtract 2 instead of add 2? Well, if our original vertex in x squared starts at the origin 0, 0, and we add 2, and now our vertex starts at 0, 2, if we subtract 2, our vertex is going to be at 0, -2. Okay, if you set x to 0 minus 2, then you know the vertex is going to be right there. Okay, the reason we want to set x to 0 is because we want to know where is the bottom of this graph going to be when it doesn't go anywhere. And as long as we start with an x squared, it's going to be on the y-axis. Okay, so we have 0, -2 right here. When we set x to 0, we get -2. That's going to be our vertex. -1, -1, 1, -1 are our other coordinates. 2, 2, so we have 2, 2, -2, 2, -3, 7, 3, 7. Boom, there's our vertex. You can stop right there. You can go on further if you want to. So when we add another variable to our equation, so we have x squared plus 2, that's going to move us up off of the x-axis. So that's basically, right now we're working with this k right here. Okay, so again, if we take this x squared, remember all of x squared stayed, the vertex was at the origin and it came up like this. If we add a number to it, it's going to move our vertex up or down the y-axis. So here we moved up, and then here we moved down. Sorry that took so long. Next video will be shorter, I promise.